Regular expression characters. A regular expression consists of literal characters and special symbols. The table and the next slide specify some of the predefined character classes that can be used with regular expressions, and we just saw an example where we used character classes or characters for certain regular expressions. For example, we used a D for integer. A character class is an escape sequence that represents a group of characters. A digit is any numeric character, as we will see in the next slide. And we saw in the example as well that for a digit we use the D that would represent any digit. A word character is any letter, uppercase or lowercase, any digit or the underscore character. A white space character is a space, a tab, a carriage return, a newline or a form feed. We used the \s for a space, but then we can also that can also be used for a tab, a carriage return or a newline. Each character class matches a single character in the string we are attempting to match with the regular expression. If you look at this table, you can see that a D would represent any digit that is from 0 to 9, but a capital D would represent any non-digit. The caret symbol over here is for the negation, and if we use it inside this square bracket, this tells us that we do not want this character at this position. So anything other than these numbers would be acceptable. Similarly, a word character is anything from capital A to capital Z, small a to small z, underscore, and any digit. And if we use a capital W over here, that will be any non-word character. This is small w, and it represents all the characters between these characters. And then we have the white space that we just saw in our example. We can use it for space or tab or any nib line. And then we have the word boundary that is represented by the /b. Replacing substrings and splitting strings. Sometimes it is useful to replace parts of a string or to split a string into pieces. For this purpose, class string provides methods replace all, replace first, and split. Just like the matches method, the string class also has replace all, replace first, and split methods. We'll look at the split method where we can split a string into tokens, and tokenization is one of the useful features that we can use where we split a given string into individual words. Maybe method replace all replaces text in a string with the new text, maybe that is passed as a second argument, and we will look at an example in a while where ever the original string matches a regular expression. So the first expression or the first argument would be the regular expression that we would want to replace, and the second argument would be the text that we wanted to replace it with. Method replaced first replaces the first occurrence of a pattern match. Method split divides a string into several substrings. To look at an example application of these methods, we have this example from your book where we have these two strings. The first string, this sentence ends in 5 stars, and there are 5 stars. Then we have the second string that contains some numbers or digits. We print the strings, and then what we do is we replace all these stars with the caret symbol, and we use the replace all method for that purpose. Similarly, when we print the first string again, we can see that we would be able to see that we have replaced all the stars with the caret symbol, and again the first replace all the stars with carets. We can replace the stars or any symbols. For example, this will be replaced by the carets in the first string using the replace all method. and we can print the output as well. Every word replaced by word, first string replace, it will replace every word, as we can see over here, anything matching this pattern. This is the pattern that we will be passing it to, or replace all method, and anything that matches this pattern will be replaced by a word for whatever reason we are trying to do this. And then original string first string and the original string 2 second string, what we want is we want to replace the first character or the first digit in our second string with this string da, the. And then there is some other replacement that we want over here. First three digits replaced by digit. This is a string, a digit. And then we can also split our string as well. We can split our string as well over here using the split method. The string class comes with a split method that will split our strings on a certain character, and that character over here is a comma. We can split our strings on spaces or any other character, maybe on full stop, or here we are splitting our string on a comma. So all of those will be separated into separate words or tokens. System.out.print ln arrays to string results, and the results will be printed in the form of a string. So let's look at the output and see what we are trying to achieve. Over here we have the original string, the sentence ends in 5 stars, as we can see over here. Then we have substituted the stars with this caret symbol. This sentence ends in 5 stars, but these are not stars, so what we do is we replace this word star with the word characters. Caret substituted for stars. This sentence ends in 5 carets, as it has been corrected now. Every word replaced by word. So what we did was we took the first string and we replaced every word in that string with this word. As we can see that this does not come in the class of words. We understand that all the digits, the underscore and the alphabets are will come in the class of words or word. So the original string is the sentence ends in 5 carets. The original string 1 and the original string 2 is 1 2 3 up to 8. First three digits replaced by a digit da, as we can see over here, and we then can split at commas that we have created an array, and we have separated all of the words of our string into this array. Let's look at this other example of the tokenizer to understand what we are doing over here. We are basically tokenizing the string. Now tokenizing is dividing the string into individual string tokens. So if you look at this code over here, what we are doing is we are taking a string from the user as input. We are storing that string in this variable sentence of the string class. Then what we are doing is we are splitting that sentence into individual tokens or individual elements. A token is, for example, this will be one token, this will be another token, this will be another token. This is how we understand languages. Our brain usually breaks the sentences that people speak into individual tokens and try to make sense of each token separately. This has many applications in text processing or speech processing or natural language processing, and this is one of the basic applications of maybe regular expressions, where we can split a sentence into tokens. If you look at this one, we are asking the user to enter a sentence, a string, then we are splitting the string based on the void spaces and then number of elements and tokens. We will print the length of the tokens and print each token separately. So let's try to run this to understand tokens. Hello, hello, how are you? How are things going? So we have asked user to enter the sentence. You press enter, and what happens is this sentence has been divided into individual tokens separated by a space. And this is called tokenization, where we are splitting the string into individual tokens based on some character. We can do it on commas or we can do it on spaces as well. Now, when we are using regular expressions in Java, Java provides other classes apart from the one provided by the string class or the methods provided by the string class that we can use to work with regular expressions. And we have a package java.util.regex that help developers manipulate regular expressions, and has a combination of several classes. We can use the patron class, the matcher class, and the string class, and there will be a new exception class for handling regular expressions. The syntax of the regular expression, as we saw, that a dot can be any character, and we will see this in examples as well, that it can be any character. A dollar symbol, if you encounter a dollar symbol, that is usually used at the end of the line. A caret symbol that is used outside of these square brackets, then that will be the beginning of the line. We usually, when we want the whole line to be considered as an expression, we use this beginning of line and end of line symbols, and this shows the range to our expression. For example, as we saw that if we have one integer in this between these two curly brackets, then we want to match exactly those number of integers. We can define our own character classes between these square brackets. Some of the classes were represented by character classes like D for digits, a W for words, a small w for words. But if we want to define our own class, as we just saw, then we can use the square brackets. The symbol is for R, used for R, and these brackets are used for grouping certain regular expressions together so that they all needs to be matched. Some characters take on special meanings inside the character class delimiters. For example, this character, when we use it inside this these square brackets, then that would mean we do not want to match that expression inside this. For example, if we enter a caret symbol and a Z over here, then anything other than a Z will be acceptable at that position. But this caret symbol at the start of the line shows us the beginning of line. We have quantifiers in regular expressions. For example, if an expression is followed by the question mark, then we want that there might be exactly 0 or exactly 1 occurrence of that expression at that position. We will not want more than one occurrences of that expression at that position. We can have 0 occurrences of that expression, or we can have at most one occurrence of that expression at that position. But if we want to allow more than one occurrences of a certain expression at a certain position, then we can use asterisk as we saw in the example. Or if we want to have an exactly one occurrence of an expression, and that can be maybe followed by more occurrences of that expression, then we can use the plus symbol. An n or any number inside these square curly brackets is exactly n times a number followed by a comma is at least n times. So there can be at least n times, and it can be followed by any number of times. And n and m would specify a range that at least n times but no more than m times includes m repetitions. Means we start with the n, m inclusive of the n and m. For example, if we have 3 to 6, then we will have a range of 3 to 6 over here. So this will tell us about the range that we can allow an expression at the number of times at that certain position. We can have greedy and lazy quantifiers. For example, all of the quantifiers are greedy by default or by the nature. This means that they will match as many occurrences as they can as long as the match is still successful. However, if any of these quantifiers is followed by a question mark, the quantifier becomes reluctant or sometimes called lazy. So the question mark will try to match as few quantifiers as expressions as possible. If then it will match as few occurrences as possible as long as the match is still successful. So if you want to maybe try and use these regular expressions that we have learned so far on the Pakistani cell phone number or CNC number or any other numbers, let's look at some few more examples of where we can use these expressions. As I said earlier that we have specialized classes in Java that allow us to use regular expressions or manipulate regular expressions, and one of those classes is a patron, and the class patron represents a regular expression. Interesting methods include static patron compiles the regular regex for efficiency, factory class that returns a patron object, string patron returns the simple string representing the compiled patron, integer flags indicates which flags were used when creating the patron, static boolean matches shorthand way to quickly execute a single match. And there is a string split method that is similar to string tokenizer but uses regular expressions to delimit tokens. We need to be careful about our delimiters. String split character sequence as input and a limit as input. Limits allows you to control how many elements are returned. A limit equal to 0 return all matches. A limit greater than 0 return limit matches exactly the number. And limit less than 0 or negative number returns as many matches as possible and trailing spaces. The value of limit is not important. In this case, just the sign of the limit is important. If a regular expression will be used only once, static patron method matches can be used. This method takes a string that specifies the regular expression and a character sequence on which to perform the match. This method returns a boolean indicating whether the search object, the second argument, matches the regular expression. We will see an example how we can use the patron class or the matches method of the patron class in a while. If a regular expression will be, so if we are using the regular expression only once, then we can use the matches method. But if a regular expression will be used more than once, for example in a loop, it is more efficient to use static patron method compile to create a specific patron object for that regular expression. This method receives a string representing the patron and returns a new patron object which can then be used to call method matcher. This method receives a character sequence to search and returns a matcher object. We will look at the matcher class in a while. The matcher class matcher contains both a regular expression patron and a character sequence in which to search for the patron. Character sequence of the package java.lang is an interface that allows read access to a sequence of characters. Matcher provides method matches, which performs the same task as patron method matches, but it receives no arguments. The search patron and search object are encapsulated in the matcher object. Class matcher provides other methods as well, including find, looking at, replace first, and replace all. Class matcher has other interesting methods as well. For example, method reset. It clears all state information on the matcher, reverting it to its original state. Integer start returns the starting index of the last successful match. Integer start with a group allows you to specify a subgroup within a match. Integer end returns the ending index of the last successful match plus 1. Integer end in a group allows you to specify the subgroup of interest. String group returns the substring of the candidate string that matches the original pattern, and we'll see some examples of this in a while as well. Group integer group allows you to extract part of a candidate string that match a subgroup within your pattern, and we will see an example of this as well that we provide. We can select a number of groups from our given string or a number of subgroups within our pattern. Group count returns the number of groups the pattern defines. Boolean matches returns the true candidate string matches the pattern exactly. The other method include find. We'll see an application of the find method in a while. Parses just enough of the candidate string to find a match. Returns true if a substring is found and parsing stops. Returns false if no part of the candidate string matches the pattern. Boolean find with an argument int start. Let's say just like its overloaded counterpart, except that you can specify where to start searching. The Boolean method looking at compares as little of the string necessary to achieve a match, so it will try to look for the first match. The find method, as opposed to the looking at method, will try to look for as many matches as there can be, but the looking at method will try to look at the first match and stop over there. So if we rewrite our program that we wrote earlier, that was a simple regular expression, and we try to now validate our email IDs with the help of the patron and the matcher class, we can see that we have this expression for our email ID. We have stored it in a string. Then these are the candidate emails in a string array. What we are doing over here is we are compiling a pattern P, and we are trying to, as we can see over here, we are compiling this pattern and we are storing it in object of the pattern class P. Now what we will do is all of the emails that are there in this array will be matched with this pattern, and in any of these are found matching, those will be, for example, we have an object of the matcher class. We look for those matching patterns and store them in the matcher class, the object of the matcher class. And what it does is the matcher class, or the object of the matcher class, then will run the find method and will look for all of the matching patterns in the matching object, and the matching patterns or the matching emails will be printed, and those that do not match will not be printed. So what we are doing over here is we are creating an object of the pattern class, and we are storing a compiled version of our regular expression in that pattern object. Next thing, we are going through our set of email IDs, and what we are doing is we are trying to match our email ID with this patron, and we are storing them in an object of the matcher class M. Then we are going through the matcher class, object of the matcher class, and try to look for the email IDs that will match this patron, and we will say that those are the matching email IDs, and those that do not match will be printed as does not match. To see an example use of the patron and matcher classes, let's look at this example where we have an expression that we want to match. So we define the expression as an object of the patron class, and we compile it as well. You can do it separately, or you can do it as an argument within the compile method as well. So we define this expression, and the expression tells that the first letter in our string should be J, and that can be followed by any character. Then there must be, if there is any birthday, for example, we want to exclude the birthdays that come in April. So what we do is we want to allow as the first letter, as if we look at this one as the first two characters, the first one may be a 0, or it can be anything between 0 and 3, and the second one can be anything between 5 and 9, including 5 and 9. So we want to avoid the birthdays in April, and that is how we can do this, that we want our numbers or digits to be this digit to be between maybe 03 and 59, but there cannot be a 4. Now the other ones can be any digits. This one is for the day, and this one is for the year, but the first one is for the month. So for example, we have a D over here, so it can be any number over here, and then this one cannot be a 4. So this is what we are looking for. Our sentence should be starting from J, and then the birthday should not be in April. And what we do over here is we call the matcher method on this object of the patron class, and we pass the string to that matcher method, and we'll try to look for the matching expressions and store it in an object of the matcher class. Match regular expressions to string and print matches to be able to print those matches. And what will happen is that the match object of the matcher class, it can be any object name, it will call the find method to look for those patrons and print those patrons in the form of a group. The matcher class has a group method that groups the similar, as we saw in the slide, it groups the similar expressions together and prints them. Let's look at the output of this. If we look at our sentences, we are passing them in the form of a single string. So we can see that Jane's birthday, we are not looking anything after the J. We want to make sure that anything with a J is returned. So we have 3 candidates for that. Dev will be excluded right over here, although the dev's birthday is not in April, but it will be excluded because the name of the dev or the string starts with the D. Next that we want to check is that the birthday should not be in April. So if you look at this birthday, this is in May, If you look at this birthday, this is in November, but it has been excluded already. If you look at this birthday, this is in April, and this will be excluded. And if you look at this birthday, this is in December, and this should be included in our search results. And if you look at the output, we can see that we have the matching results. Let's look at some other examples. For example, if we want to see how the grouping works, we have this string as a candidate, and this is the kind of groups that we are looking for in this string. So the group should have a word, and that word should be followed by a digit. If we look at this string, we have three such kind of examples: J2, J5 and H7, and we'll try to see if our pattern returns these matches. So we compile the expression as we do, and we store the matching candidates in the match object of the matcher class, and then we go through the object of the matcher class to find them and print the matching patterns, and we will do this in the form of group them together. So if you look at the output over here, we can see that we have J, the first one, all of these have been returned. So the matching patterns have been returned to us. There is the J2, J5 and H7 in the form of groups.